Let us consider 4 circles. Divide the first circle in 2 equal parts and shade one part. Divide the second circle in 4 equal parts and shade 2 parts. Now, divide the third circle in 6 equal parts and shade 3 parts. Lastly, divide the fourth circle in 8 equal parts and shade 4 parts. We can observe that the same part of the circle is shaded in all the figures. Thus, 1 upon 2, 2 upon 4, 3 upon 6, 4 upon 8 represent the same portion of the circle and are equal. 1 upon 2 equals 2 upon 4 equals 3 upon 6 equals 4 upon 8. All these are equivalent fractions. To form equivalent fractions of a given fraction, the numerator and the denominator are multiplied or divided by the same number. By multiplying or dividing the numerator and the denominator of a fraction by the same number, except 0, its value does not change. For example, let us find the equivalent fractions of 1 upon 2. Multiplying the numerator and the denominator by 2, we get 2 upon 4. Multiplying the numerator and the denominator by 3, we get 3 upon 6. Thus, 1 upon 2 equals 2 upon 4 equals 3 upon 6. Similarly, we can even divide the numerator and the denominator of a fraction by the same number to find its equivalent fractions. Let us take the fraction 4 upon 8. Dividing the numerator and the denominator by 2, we get 2 upon 4. Dividing the numerator and the denominator by 4, we get 1 upon 2. Thus, 4 upon 8 equals 2 upon 4 equals 1 upon 2.
Write the next 4 equivalent fractions. 1 by 5 is equal to 2 by 10 is equal to 3 by 15 is equal to dash. The numerator and the denominator of 1 by 5 is multiplied by 2 to get the next equivalent fraction 2 by 10. When we multiply the numerator and the denominator of the fraction 1 by 5 by 3, we get 3 by 15. Similarly, we can multiply the numerator and the denominator of the fraction 1 by 5 by 4, 5, 6 and 7 to get the next 4 equivalent fractions. Our answer is 4 by 20 is equal to 5 by 25 is equal to 6 by 30 is equal to 7 by 35. Two fractions are said to be equivalent fractions when the product obtained on cross multiplication is same. Two fractions are equivalent if numerator of the first into denominator of the second is equal to denominator of the first into numerator of the second. Let's consider two equivalent fractions 1 by 2 and 2 by 4. Cross multiply them. Numerator of the first fraction, that is 1, into denominator of the second fraction, that is 4. So 1 into 4 is equal to denominator of the first, that is 2, into numerator of the second, that is also 2. So 2 into 2. What is the answer that we get when we multiply 1 by 4 and 2 by 2? We get the same answer, that is 4. So we can say that 1 by 2 and 2 by 4 are equivalent fractions. Find the missing numerals. 3 by 4 is equal to dash by 16. We can read this question like this. Find the equivalent fraction of 3 by 4 with denominator 16. Here the numerator is missing. We know 4 is a factor of 16. So what is the other factor? 4 4s are 16. So we can multiply 3, the numerator, with the same factor 4. 3 4s are 12 by 4 4s are 16. So our final answer is 12 by 16. This problem can be solved in one more method, that is called cross multiplication method. Follow the arrow marks. 3 into 16 is equal to 4 into dash. We have to bring the 4 to the other side of the equal to sign. Then the multiplication sign becomes division. 3 into 16 divided by 4. 3 into 16 divided by 4, we get 12, which is the numerator. Even in this case, we get the same answer, 12 by 16. Change the following fractions into an equivalent fraction with numerator 18. The question is 54 by 84. We need to find a fraction with a smaller numerator. In this case, we are supposed to do division. We know 18 is a factor of 54. 18 into 3 is 54. So we divide the numerator and the denominator by 3. We get 18 by 28 as our answer.
I want my fair share of the gold, or my share of the boat.
Sorry to butt in like this, but we need a ride across the river.
Sorry, we're out of business.
What is the problem here?
The problem? You want to know what the problem is? You tell us.
You see all this gold? Half is mine and half is his.
And when we try to split it up, one piece for you, one piece for me, there's always one piece left over. Give it to me!
Hold on to your horns. I count 15 here. I don't know how to share 15 either.
Maybe we can.
But that thing with the big beak just said we can't.
Here's an idea. Will you take us across to the cave if we help you divide the gold equally?
Well, and here's an idea for you. If you can't...
That was awesome.
Listen, Goat Man. Do you realize my friends here have the power to give you both an equal share of gold? Huh?
Okay, you have a deal.
Start the sharing.
Okay, this one looks like a whole bar of gold. Maybe all these smaller ones are parts of a whole bar. You follow me?
Right.
Yeah, we knew that.
So let's start by separating the different sized pieces.
Try putting the bars in rows, largest to smallest.
Hey, look at that. 2 of these bars are the same as the one big bar.
Which means each smaller bar is 1/2 of the whole bar.
And 4 of these bars also equal one big bar.
Yeah!
So each of these is 1/4 of the whole bar.
And it looks like it takes 8 of this size bar to equal the whole bar.
Which means each one of these bars must be 1/8 of the whole bar.
So, how do we share them?
Simple. You get the whole bar.
Hey, what about me?
And you get the 2 half bars. The same as one whole bar.
Oh, that's better.
Now you get the 4/4 bars because 4/4 is also the same as a whole.
And you get all 8 of the 1/8 bars because 8/8 is the same as a whole.
Shares of gold.
Hooray!
But your shares, you just...
It doesn't matter. We're friends again.